are a number of distinct advantages to Agile methodologies, but for many projects, a more structured approach, such as Waterfall or one of its derivatives, is required. Waterfall has been around for a long time as a slow, structured development process. Requirements are created and reviewed. An architecture is developed and it is reviewed. Then detailed design, development, and test with a review for each of these. And of course, although not shown, there will always be feedback from one stage to the previous stage, such as from architecture to requirements. For many projects, this is just too slow. It also breaks down when requirements are very volatile. To deal with these shortcomings, radically different processes were developed, especially for software development. Agile is one such approach which has become very popular because of the distinct benefits it offers. Agile breaks product development into a sequence of short, fixed-duration iterations. The team starts by prioritizing features and selecting a group that can be completed within the specified duration. When this iteration is done, other high-priority features are selected and implemented in iteration 2. This is continued until all of the features have been implemented and the product is complete. Frequently, the features are reprioritized before choosing what is in the next iteration, which makes Agile very adaptable. Also, Agile doesn't ignore the waterfall processes, rather each is dealt with as necessary during the iterations. There are two distinct advantages to the Agile approach. Useful intermediate products are available early, and testing is continually performed on a product which is incrementally taking shape. This assures a high-quality product that the customer can use. Unfortunately, this approach is not feasible for many projects. Going back to the waterfall, many organizations cannot just abandon waterfall for Agile. Frequently, it is essential to develop an architecture upfront since the features cannot be directly implemented. There must be some type of framework or infrastructure before any user functionality can be added. And the requirements and architecture are usually developed by a few senior resources before the project team has been identified. Typically, project team members start coming on board during architecture development, and they need time to come up to speed. And finally, many of the team members are specialists. They are assigned to the project for very specific tasks. This requires careful planning to spread the work evenly over the team. Recognizing that waterfall takes too long, there are ways of improving it. Many organizations use a modified process which allows for overlapping stages. That is, architectural design starts when the major requirements are understood, but before they have been fleshed out. Detailed design can start when the architecture is reasonably mature. Development can start before the detailed design is complete, and testing can start before the development is complete. Now, in my experience, too often the project managers and developers do not take advantage of starting testing as soon as possible, and some leave way too much to the end. After all, it's the development, not the testing, that's fun. I've seen a number of projects where dealing with the many defects left in has led to utter chaos near the end. There was no idea of when testing would be complete. Therefore, testing should start as soon as possible with time at the end for overall system-level testing. When using waterfall, detailed planning usually occurs as the architecture is being developed. Management has many legitimate reasons for wanting a plan. It drives the business case, it's used to set customer expectations, and knowing when resources free up is essential for long-range planning. And as we'll see, proper planning can make waterfall incremental, that is more agile-like, and thus also lays out how to start testing as early as possible. But this is really not incompatible with Agile. Agile does recognize that some projects will require an iteration 0 to lay out a basic architecture and a high-level plan of the project. Agile planning is rather simple. Typically, a release plan is created that estimates how many iterations will be required and does a first pass at mapping features into those iterations. Of course, this is subject to change once the iterations are started and more is known. But in fact, this is no different from any project plan. They're all subject to change. What the release plan does is provide a rough prediction of when the project will be completed, something that management needs to know. So creating an architecture and a plan up front is in fact consistent with Agile. What we need to do is lay out a plan that breaks the work into chunks such that the end product is developed incrementally. These need not comply with the Agile rules, such as each iteration must have a fixed duration, because the real benefit is achieved when using an incremental approach. In fact, for many years, I have been doing this in an approach that I call schedule-centered planning. Schedule-centered planning simply recognizes that a realistic schedule must reflect all aspects of planning, including risk, quality, and procurement planning. A unique element in this approach is what I call the strategy. The strategy is the game plan, the big picture view of the schedule. Early on, the product is broken down into small, manageable pieces. The strategy then lays out the best sequence to create and integrate the pieces together to incrementally build up the end product. Typically, the features drive an architecture, and the architecture defines the major pieces of the product. Then each of those pieces is further broken down. While this divide and conquer approach might be continued to lower levels to fully understand the size and complexity of the project, we can stop here for demonstration purposes. With the basic pieces defined, it's necessary to shift gears and think about a sequence of intermediate products that starts from something very basic and builds on this until the end product is completed. For example, if the project requires adding third-party software to a legacy system, the first stage might simply be to demonstrate one or two key features of that software working together with the legacy software. For our PBS, elements 1.1 and 1.2 might represent the features of the third-party software, and element 2.1 represents a necessary change to the legacy system. Then, to perform the simple demonstration, these three elements must be developed and integrated together in what I'll call Stage 1. Next, we might decide to add more of the third-party functionality, here element 1.3, with more legacy changes, 2.2, and new features added to the legacy, 3.1 and 4.1. As before, each would be developed and integrated with the results from Stage 1 to produce more complex and more useful functionality. This process is continued until all of the pieces of the PBS are created and the final product is built. The start and finish for each integration stage will depend on the complexity of the pieces that must be developed. Simple pieces might take a few days or weeks to create, while complex pieces might take over a month. Thus, the strategy is driven by the incremental development of meaningful, fully tested functionality, not by trying to fit development into a sequence of fixed duration time boxes. Now, in my experience, many technical people are capable of developing an ad hoc strategy to incrementally build their end product. They will instinctively get something simple working as early as possible. However, they do minimum testing to demonstrate functionality and then move into the development of the next stage. At the end, it's necessary to integrate a large number of minimally tested pieces, which can be a lot harder than was envisioned. Thus, a formal strategy similar to the Agile release plan must be developed. In addition to identifying the pieces to be developed and integrated, as is shown here, the planned functionality for each stage must be defined along with appropriate testing to verify that all functionality in the current iteration is working properly. But as this shows, with proper planning, you can achieve a more agile waterfall process.